Here I try to give an easy explanation of the transverse nature of electromagnetic waves. It is generally stated that as a consequence of the Gauss theorem, the waves of electric field and magnetic fields are perpendicular to the direction of propagation in an electromagnetic wave. I have tried to give a simple argument and show that how we can explain the transverse nature of the electromagnetic wave. Let us start from the Gauss theorem, which is divergence of E equal to 0 for a charge free space in integral form. The same equation can be written as integral over a closed surface E dot ds equal to 0, where ds is an infinitesimal area over the closed surface. Let us imagine a dipole comprising of plus q and minus q charges separated by an infinitesimal distance between them. This dipole is oscillating, and as a result of which electromagnetic waves will be radiating out. Let us imagine a sphere of radius r with a center at the center of the dipole. On the surface of the sphere, we will have E dot ds equal to 0. This is because the total charge enclosed by the sphere is equal to 0, as plus E plus q will cancel with minus q. Now since this is 0, on every surface element ds, we must have E dot ds is equal to 0. Since the direction of ds is along the radius vector r, so the electric field must be making an angle 90 degree with the radius vector r. And since the electromagnetic waves are propagating along the radius vector r, the electric field must be perpendicular to the direction of propagation. In a similar fashion, we can show that because divergence of B is equal to 0, the magnetic field will also be perpendicular to the direction of propagation in case of an electromagnetic wave. The situation can be generalized for any geometry other than sphere as well. And this way we are able to show that the electric wave and the magnetic wave, they are perpendicular to the direction of propagation of the electromagnetic wave. Thank you for watching. If you wish to contact me, you can write to me in the following email address: Dr. Atish Mazumdar @gmail.com, or give me a friend request in the Facebook account Dr. Atish Mazumdar. Thank you.